Hi, everyone. My name is Carlos Marin, and I'm a product manager for Chrome browser focused on enterprise and integrations.
And I'm Markus, product manager at the Chrome OS Enterprise team.
Perfect. We'll both be live in the chat, so feel free to post any questions for us during this session. So, the world has really undergone a huge change and an evolution. And most companies predict that we are not going back. Our ways of working have fundamentally evolved to be remote and distributed. Endpoint computing is happening at home, in the office, and everywhere in between. And the technology that supports it has evolved as well. We really see it in the numbers and when we look around in the way that we are working together right now. And it's not only the way that we work that is changing, but it's also the online threats that are evolving. You can see it in the Safe Browsing Transparency Report that we publish every year. Safe browsing helps protect billions of users on the web across many platforms that span mobile and desktop. When we look at the trends, it's seen fewer sites that are attempting to directly distribute malware, but there's been a steady rise in the number of sites that are associated with phishing campaigns. A single employee falling prey to a phishing incident can cause very significant damage if you don't have the right security measures in place. This is a good example of an area where enterprises have had to stay vigilant and where IT administrators have had to work on increasing the security measures that they deploy against these threats. The results of all these trends is interesting. Your employees are likely spending most of your time in the browser because it's where the modern apps that power businesses run. The browser is that window to the web, and now to external communications with your employees. And that's the case across most of the devices and operating systems that are deployed in the enterprises today. It's not enough to think of the browser as just another app, because it's what's enabling a huge portion of your employee productivity. It's where your employees are interacting with the outside world to get work done. While it's an app, it's one where you really need to think about it from a security perspective. For us at Google, it's been an opportunity to rethink how we approach major elements of our own enterprise security measures. And in particular, for how we approach important pieces of the enterprise security puzzle, such as access, threat protection, securing enterprise data directly from the browser. Let me walk you through how we're approaching each of the security pieces. A key insight as I step through the different pieces is that at Google, we really see Chrome as an extension of our cloud computing environment. We support a broad range of corporate devices for our employees, all of which run Chrome. And Chrome on those devices starts with all the great security features that billions of users know and love. Chrome even pioneered a lot of the security features that is at the baseline of modern browsers today. Great examples of this are our approaches to high-level, user-visible security features such as auto updates and safe browsing. But under the hood, we also pioneered security features such as sandboxing and site isolation, which provide users with a significantly more secure and robust browser. These features are a major reason why Chrome is consistently a hard target for hackers to crack. And we see that when we look at the cost of a sandbox escape. But for most IT administrators, deploying Chrome isn't enough. Enterprises have a really broad set of needs when it comes to a browser. They need to be able to do things like deploying enterprise specific presets. These presets might be preloading bookmarks for a set of often used enterprise resources, or simply other configurations that make it easier for employees to access network resources, or that control which features of the browser should be enabled or disabled at work. Many also need fine-grained control for when Chrome updates. And they need to be able to manage these extensions, which extensions can be installed on corporate devices. For all these things, Chrome includes a very rich set of enterprise policies that can be used to control these features. And while it's possible to configure Chrome by setting enterprise policies on each platform where you're using it, where things get interesting is when you start managing from the cloud. With Chrome Browser Cloud Management, administrators can manage every aspect of Chrome directly from the cloud. You benefit from being able to use a single console to manage Chrome across every major platform. And you get the benefit of getting additional visibility into your deployment. You get access to reporting features such as Chrome Version Report, which shows you exactly what version of Chrome is used on each of your managed devices, as well as the Extensions Report, which shows you exactly which extensions are used across your fleet. And cloud management is the foundation for deploying more advanced enterprise security features. Once you're managing Chrome from the cloud, you can start layering in the security features that you need without having to go and muck in with the endpoint. In today's talk, we'll cover exactly how this works to layer 3 additional enterprise security features in Chrome. The features that I'll mention today are part of BeyondCorp Enterprise, Google Cloud Zero Trust product offering, and they're a good example of what's possible with this approach. These work the same way that Chrome Browser Cloud Management. You configure BeyondCorp access, threat protection, and enterprise data security features directly from your cloud console, and that results in these security features being deployed across your managed Chrome endpoints. And if you're using Chrome OS, you not only get access to all the security benefits that I mentioned at the app and browser layer, but you also benefit from Chrome OS and firmware level security features, making it easier and simpler to get an enterprise device that is fully locked down. This includes firmware that prevents tampering with the OS image, the ability to encrypt user data at rest, and an approach to computing that reduces the on-device data footprint that makes it trivial to keep the entire system up to date with automatic patches and updates. If I had to summarize what you'll see in this deep dive is that our approach brings most of the benefits of cloud-based security models directly to the browser. But because we're applying them directly at the point of the user interaction, we're being able to deliver the security benefits in a way that it's a lot simpler for administrators to deploy and that causes far less friction for end users. And we're not doing this alone. Chrome Enterprise brought together an alliance of partners late last year under the Modern Computing Alliance. Okta is one of those partners, among others, and we're all working together to drive innovation from silicon to cloud. That innovation includes security, and the collaboration between Chrome Browser, OS, and Okta is really key to helping organizations offer the safest and most productive modern computing platform for your workforce. We're really excited about the work that Chrome Enterprise and Okta have planned together, focused on helping customers advance on their zero trust journey. Keep an eye out for more details later this year. We're also doing more work together with Okta and Chrome OS specifically. So at this point, I'd like to invite Marcus to share a little bit more about our collaboration taking place between Okta Workflows technology and Chrome OS.
Yes, absolutely. So thanks, Carlos, for the great overview of the challenges that we see in a work from home environment. And by you, I think we'll give an overview of how we plan to address these challenges in just a few seconds. I now have the pleasure to present the first concrete outcome of the intensified partnership between Google and Okta. So as you might know, last year at Octane, Google joined Okta on stage during the opening keynote to discuss our emerging partnership and the importance of providing customers with flexible identity and choice. Since then, our two companies have been working together to make identity secure and simple for users of Chrome OS devices. As a first step of this partnership, we worked with Okta to ensure Chrome OS could be properly integrated with the Okta Workflows platform. Our target is that IT administrators can simply integrate Chrome OS and the Okta workflow logic and deploy quickly without any coding. To showcase this integration, we have built the ability to require users to re-authenticate on their Chrome OS device once Okta has detected that the user has changed their Okta password. Let's have a look at the demo. So in this video you see on the screen, you will notice that the user is already logged into a session and navigates to a standard Okta password update page to change their Okta password. Okta Workflows now detects this password change and triggers a re-authentication for that user on all Chrome OS devices. During the next login, the user is prompted to update their local password on the Chrome OS device. You just see this red notification prompt that appears on the page. The user just needs to click on it, on the prompt, log in with the new credentials, and they are all set. So prior to this integration of Okta workflows and the Chrome OS part, password changes created some frictions for Okta end users on Chrome OS devices. So while the Okta password was changed on the server, the Chrome OS device was unaware of this change and could therefore have a different local password. The work we just did here ensures that this is no longer an issue. So if you are like a customer of Okta workflows, have Chrome OS devices in your fleet, and would like to test this feature out, please sign up for the Trusted Tester program at g.co/Okta-Chrome OS. And finally, let me also add that you can use this integration not only to trigger a reauthentication in case of a password change, but also in a variety of other cases. For example, if the user just traveled to another country, so depending on your security requirements in your company. So to summarize, the integration of Chrome OS and Okta workflows gives IT the ability to strongly adapt the identity flows of Okta users on Chrome OS devices. And with that, let me hand it back over to Carlos to talk about the larger picture and the upcoming improvements.
Thanks, Marcus. Now let's go back to our challenge. But what if we could change the rules of this game that we're playing? I think that's it's the time with a new normal and a new IT environment and a new work environment that is remote, hybrid, and distributed. We need to really change the way that we approach security in the enterprise. Rules that embed security into every workflow to provide proactive protection to users, devices, applications, and data wherever work happens. Proactive, not reactive. That's what's important. So, number one, be cloud first. Let's start with the most basic layer when extending your cloud security architecture, managing your browser through Chrome Browser Cloud Management. The way that this works for Chrome running on desktop operating system is through Chrome Browser Cloud Management, a simple token-based enrollment scheme that allows you to manage and audit machines running Chrome. On Chrome OS, Google Cloud's native operating system, device management and reporting are built into the platform themselves and is automatically enabled when Chrome OS devices are enrolled into management. Token-based enrollment is a frictionless and easy-to-deploy solution that can bring existing Chrome deployments directly into the cloud by simply pushing a token to your devices using your existing platform management infrastructure. On next restart, Chrome will register with Google's Cloud Management Console for your organization. This is available today at no cost for Windows, Mac, and Linux, and is coming soon to Android and iOS devices too. An administrator logs into Google Admin Console at admin.google.com using their existing account. Once signed in, an administrator can create or import an organization's unit structure as needed. For each organizational unit, an administrator creates a token in which format is most convenient to their deployment scenario and places it on their managed endpoints. Chrome will notice the token and enroll against Chrome Browser Cloud Management, providing a set of powerful policy configurations and reporting capabilities integrated right into the browser. Once enrolled, a host of available functionality is immediately available at no cost, including detailed policy controls that allow you to configure Google Chrome on all supported platforms from a single place. In addition to pushing policy to your Google Chrome endpoints, Cloud Management makes available detailed reporting about the state and health of your Chrome fleet, from extensions that are installed on your managed Google Chrome instances to version reports showing whether your users' browsers are up to date. Chrome Browser Cloud Management brings immediately and actionable insights into your Chrome deployment. It is worth noting that this takes place in the same console that is used to manage Chrome OS, Google Workspace, and many other Google Cloud products. On Chrome OS, all of this and many additional device-level management capabilities are built in natively to the operating system as part of the Chrome Enterprise upgrade. Now, once Chrome Browser Cloud Management is deployed to your endpoints on all supported operating system, and again through the simple and low-cost mechanism of deploying a token to any device that has Chrome installed, the technical foundation is now in place to unlock a host of cloud-powered security features. Chrome's built-in policy management and cloud reporting channel underpin the deploy of a new suite of security services. So number 2, sandbox everything. Sandboxing everything prevents malicious web pages from installing malware and stealing data. Chrome browser uses sandboxes to contain threats to a single tab and can contain a single process with site isolation. Chromebooks take this a step further by ensuring all applications and OS processes are kept separate from each other. Containerized apps run all on their own without interacting with other software, and in particular, the OS. From a security perspective, that means that there is malicious, or if there's a malicious or insecure code in any app, any compromise stops with the app and doesn't spread to the whole OS. Encryption has been one of Chrome's core principles from the very beginning. So this is why number 3 is default to encryption. Natively, 5 years ago, we've helped pioneer encryption on the web. We began making all sites not encrypted with HTTPS as not secure, making it easier to know whether your personal information is safe as it travels across the web. With Chrome OS, data is kept in an encrypted partition to ensure it is accessible offline while keeping file systems inaccessible by end users. Plus, files on the device are encrypted using tamper-resistant Google security modules that use Google's proprietary security chip, Titan-C. Titan-C chips are built into Chromebooks. They are always on, require no configuration to enable, and allow for enforcing policies remotely. And as a result, there are 2 binaries on every Chromebook that ensure devices stay secure, protect user identity from logins on remote devices, brute force attacks, and phishing scams, and prevents the OS and encryption keys from being compromised. If there's a risk that the OS has been tampered with at the firmware level, the OS is updated prior to launch. And when there's a known compromise, you can rest easy knowing that Google will push out a fix to all Chromebooks rapidly as soon as a solution is known. Number 4, always up to date. All the updates on both OS and browser happen automatically and in the background without downtime or end user interruption. Feature updates for Chrome OS are available every 6 weeks, with security patches every 2 to 3 weeks. For Chrome browser, you can also configure and customize auto updates to have them occur outside of regular business hours, or stagger them to reduce bandwidth issues. Whatever works best for your users and your organization. Number 5, protect users in real time. BeyondCorp Enterprise is a Google Cloud security offering based on the BeyondCorp technology developed at Google that helps organizations move away from traditional network perimeter-based security, modernizing their infrastructure for a distributed, cloud-native world, where new approaches to securing distributed systems. BeyondCorp is a zero trust security framework that shifts access decisions away from being based on network segmentation and towards access decisions based on user and device authentication and authorization. This technology underpins Google's internal approach to network security and is now generally available as BeyondCorp Enterprise. Chrome and BeyondCorp Enterprise work together to protect users in real time, where threats happen in the browser. And this protection can be extended to the operating system with Chrome OS. A full BeyondCorp deployment involves many components at the layers of cloud services, networking and user identity, and device inventory. You can learn more about what a full deployment looks like at cloud.google.com/BeyondCorp Enterprise. But for this talk, let's focus on a critical component when deploying and managing a BeyondCorp solution, and the way that Google Chrome running on your endpoint significantly eases the deployment, while also preventing additional layer endpoint protection directly from the browser. There are several different capabilities that Chrome brings to your devices as part of BeyondCorp Enterprise. Let's start by taking a look at how Google Chrome facilitates one of those core use cases, access. As organizations transition to the cloud, the limitations of older network perimeter-based access models no longer suffice. The cloud access and security model is evolving towards zero trust architectures, pioneered at Google in the form of our internal implementation of BeyondCorp. The core philosophy of a zero trust model is to gate access not on where a device is connected to, but rather to collect a series of signals and data points about the user and the device context, and then base access decisions on those signals according to the policy an organization has set up. A variety of signals can be collected and can come into the access decision, including everything from device management status to whether the device is up to date with patches and security policy. In non-browser native solutions, these signals are often collected from via native agents deployed on the machine. These agents then will insert signals into requests made by the browser during authentication flows, often by injecting data into the browser's network requests. These approaches, while widely used, is strictly more complicated and brittle for more browser-based access workflows employees use on their day-to-day roles. They suffer from the need to deploy and manage additional components, and depending on the approach, to intercept and modify outbound network traffic, incurring additional performance overhead and complexity. In a browser-native solution as provided with Google Chrome and Beyond Chrome Enterprise, this signal connection and injection can happen right within the browser, vastly simplifying the configuration overhead and inserting the right signals to make access requests at the right time. Building on top of the Google Chrome's cloud management capabilities and leveraging Google's endpoint verification browser extension, Chrome is providing integrated signal collection and additional signals being added on an ongoing basis. In addition to contributing to simplifying the deployment and management of zero trust access use cases, Google Cloud Security capabilities integrated into Google Chrome further add to your organization's end-to-end security posture. The next layer of endpoint defense comes in a set of threat and data protection capabilities built into Chrome browser, powered by Google Cloud's threat detection services. Let's take a quick look. The new threat and data protection capabilities integrated into Google Chrome, built on top of Chrome's cloud management integration, are themselves powered by Google's state-of-the-art cloud security products like Cloud DLP and Safe Browsing. Google scans billions of URLs and binaries across the web and are incorporating this information and intelligence and coupling it with ML models to protect our enterprise users in real time. Our multi-level static and dynamic analysis helps prevent data leakage and web threats and provides alerts for all unsafe events. Users can get capabilities of a CASP or SWG in a browser without man in the middle. The ability to deliver these capabilities to someone outside of your organization, such as a contractor or vendor, is a powerful tool. Admins and security analysts can now view summary and detailed reports of all unsafe activities, integrating endpoint risk assessments into your security and compliance practices. And now finally, number 6, tamper-proof the OS. Extensions have access to special privileges within the browser, making them an appealing target for attackers. If an extension is compromised, every user of that extension becomes vulnerable to malicious and unwanted intrusion. Chrome allows admins to use a permissions-based approach to extensions, rather than limiting employees with blocks and allow lists. Chromebooks use verified boot to confirm that the operating system is safe. With 2 versions of Chrome OS on every device, your Chromebook can proceed to boot up even if one OS has been tampered with. With Chrome OS, you can run locally executable apps, not malicious .exes. Altogether, this means no antivirus is required. I know we've covered a lot today, and hopefully this session has given you a good overview into what you can do today with Chrome Enterprise Solutions to improve your organization's security posture. We've also given you a glimpse into our upcoming work with Okta, which is very exciting. Here are some helpful links from today's session, if you want to take them down. We can also invite you to engage and interact with us at Octane's Expo Hall Hours to chat with me, Marcus, and other Googlers. We'll be taking Q&A here for this session until the top of the hour as well. If I have to leave you with one parting thought, is that it's time for a change in the way that we transform and the way that we think about security. For new rules based on cloud management and zero trust, and for a change to take back security control. If you want to learn more, come chat with us at Chrome Enterprise. Thanks for joining us today, and enjoy the rest of Octane.